Showing number 4, what are the objects that are involved in this situation, in this one?
The laundry bag and the cart.
Yep, the laundry bag and the cart. I'm going to be lazy and just call it the bag. Is that okay? And the cart.
It's frozen.
Oh, it's frozen, so you can't see all the loveliness? Yeah, you can. All right. So we got the laundry bag and the cart. What's the mass of the laundry bag? 22 kilograms. What's the initial velocity of the laundry bag? Is that right? Zach does not agree with you. Why don't you agree?
Oh, no.
Because we need to find the velocity.
Right. What is that 3.0? That's the final velocity, right? So the initial velocity, this one's a little bit different than the ones we've done before because the question mark comes really early on. So there's the question mark. So our initial momentum here is just going to be 22 kilograms times VA sub I, the initial velocity for object A. Again, as I said yesterday, if you want to call this like B and C for bag and cart, that's cool with me. I'm just going to go with the letters that we have up here just to kind of stay consistent. Okay? All right. What is the mass of the cart? 9 kilograms. What is the initial velocity of the cart? How do you know it's 0? Stationary. Stationary means not moving? Absolutely. What's the initial momentum of the cart? What is it?
0.
It's 0 kilograms, right? Kilogram meters per second. Thank you. Because remember, momentum is mass times velocity. All right. So before we move on to the after part, let's go ahead and write down our initial piece. So initially, the momentum is 22 kilograms times VA sub I plus 0. All right, let's do the after. So the masses don't change. You've got 22 kilograms for the bag and 9 kilograms for the cart. What is the final velocity for the bag? Three meters per second squared? Or meters per second, excuse me, no squared on that one. What's the final velocity for the cart? 3 meters per second, right? Is this an elastic or an inelastic collision? Inelastic, right? Just a little note there so that we know it. The final momentum of the bag. What is the final momentum of the bag? .66 kilogram meters per second. So 22 times 3. And the final momentum of the cart is? You got it? So then I'm going to go ahead and write down those two things down here in the big equation. So I've got 66 kilogram meters per second plus 27 kilogram meters per second. That gives me a total of, what is that, 93 kilogram meters per second? So basically what we've done is set up all of the givens. Any questions on that? I hope I'm not going too fast. Issues or questions there? We're okay? Okay. So now we're just going to take these two things and set them equal to each other. So we got 22 kilograms times VAI equals 93 kilogram meters per second. So let's go ahead and write that down. So we got 22 kilograms times the thing we don't know is equal to 93 kilogram meters per second. How do I get the VAI all by itself? Divide by 22. Sorry, I totally just stepped all over your great answer there. I apologize for that. And that gives us the initial velocity for the bag of something. 4.23. Okay. Yeah.
Are we gonna have these charts on the quiz?
Yes, I will give you a chart like this.
And are they gonna be both like these types of problems, and they're gonna be like conceptual problems, or is it like one or the other?
So I haven't written the quiz,
Okay.
and so I can't like guarantee you, but what's in my head, what my idea is you'll have one or two problems like this,
Okay.
and then you'll have one or two either graphing or conceptual or something like that problems as well. Does that make sense? Yeah. All right. Before we move on, because it's great practice and because you will see it on the quiz on Monday, I haven't written it, but I'm sure that it will be included. Let's go ahead and write down your D versus T graph. What's that going to look like? I had a couple people last period that were like, I get them once you do them, but before you do it, I don't know how to do it. I don't know how to draw the graph. Start with something, right? The bag is moving at a positive velocity. What does the cart look like before the collision? No slope, because it's not moving. Slope of 0. Collision happens. Then what? Absolutely. They both keep going at a less steep angle. So something like that, maybe that's maybe a little too less steep, but you get the idea. Let me do it a little bit better. Something like that. Sound okay? Are there any other homework questions that you guys would like to go over? Yeah.
Can you do 213 number 2?
Sure. Does anybody need to keep seeing this, or can I keep going? Is that okay? Say it again. You said 213 number 2. Is that right? Sure thing. Okay. So 213 number 2. Oh, yes. This is the golf balls?
Yeah.
Yeah. Speeds as high as 273 kilometers per hour have been recorded for golf balls. Okay. Suppose a golf ball whose mass was 45 grams is moving to the right at 273 kilometers per hour. That is really fast. Yeah. Strikes another ball that is at rest. If after the perfectly elastic collision, the first golf ball moves with a velocity of 91 kilometers per hour to the left, and the second ball moves with 182 kilometers per hour to the right, what is the mass? This one's weird, right? Because it's asking you for a mass. Okay, so we've got two objects. There's not really any way to tell them apart. Oh, they have different masses though, don't they? So we'll maybe do like the big one and the little one. Should we do that? Big one and the smaller one. All right. Well, I guess we don't know if it's bigger or smaller, do we? Oh, okay. Let's not even do that then. Let's just call them A and B. All right. So you got one, the 45 gram one. Let's do that one first. Is it a big deal that it's in grams? Doesn't matter. I mean, as long as everything else is consistent, and when you're writing out your units, then you say grams at the end as well, you'll be okay. Yeah. If you want to convert it to kilograms because it makes you happier, it makes you make it more sense, do it. That's cool. The one that is 45 grams moves to the right, and it says 273 kilometers per hour. Same thing with kilometers per hour. Do we need to convert it to meters per second? No, because everything's in kilometers per hour. It says it strikes another ball that's at rest. So before we figure out the total velocity, or excuse me, the total momentum before. So 45 times 273 is 12285. Oh, excuse me. I have to write this out right. So this is grams, kilometers per hour. That's weird.
So when you have like big things like planets that are moving really fast,
Yeah.
it should be really
True. Yep. Which is why we use scientific notation to make our lives better. Yeah. So the other ball, we don't know the mass of, right? So that's our question mark. It says that its velocity at the beginning is how big? 0. So that means that even though we don't know the mass, we know that the initial momentum is 0. Does that make sense? So it's still 0 grams kilometers per hour. So then you've got 12285 plus 0 gives you a total of 12285 grams kilometers per hour. So far, so good? Okay. Other side, same things we know and we don't know. 45 grams, question mark. This one, the directions are important, I think, because it says that the 45 gram golf ball is moving to the right at 273. So we're going to call that a positive, as opposed to after the elastic collision, the first golf ball moves 91 kilometers per hour to the left. So that means it needs to be a negative. Absolutely. So it's going to be negative, was it 91? So we can do that. We can say 45 times 91. That's going to give me a negative 4095. Says the second golf ball. My friends over here, can you be just a little quieter just so I can hear myself think a little bit better? I'm not saying you can't talk. Just kind of whisper as opposed to, yeah. Thank you so much. The second ball moves to the right at 182 kilometers per hour. So is that one going to be positive or negative? So this one is going to be 182 kilometers per hour times the mass. That's what we don't know. Mm-hmm. Yeah. So literally every time I'm just going to multiply these two. And if I have a question mark, I'm just going to write the thing I don't know. Does that seem okay? Okay. Right. This one's a little funny because we don't know the mass. But it's the same process. It's just a different thing you have a question mark about. So then this is going to be negative 4095 plus 182 kilometers per hour times the mass of B. We can't really simplify that, so I'm just going to leave it like that. And then underneath here, I'm going to write the left side is equal to the right side. So we'll just write it down. And that all comes, again, ladies and gentlemen, from that statement there, right? All comes from that statement. So here we go. So we're going to say 122.85 gram kilometers per hour is equal to negative 4095 gram kilometers per hour. I got kind of lazy there. Sorry about that. Plus 182 kilometers per hour times MB. So that's where that equation comes from. Okay. So I've got one number equals the negative of a number plus a number times my thing I want to know. So I just got to peel the onion back just like always. So right now I'm subtracting a number. How do I undo subtraction? Add it. So I'm going to add 4,095 to this one over here. So that's going to give me what? 5, 8. It didn't line it up well. 3, 6, 1. Did I do that right? Somebody check my addition skills. I had it right.
I don't know. I don't think that's right. Yeah.
Oh, 80. Duh. Yeah. That was just a silly mistake. Silly me. 80 All right. And then how do I get the MBL by itself? What did I do wrong? Did I screw something up? Let me know, guys.
No, it shouldn't be 82, just the 5s.
Well, yeah, we got to divide by 182. So what do you get? So MB equals 90. 90 what? Grams. How do I know that? Because I've got a kilometers per hour on this side, kilometers per hour on this side, and so I'm left with just grams. Yep. What's up?
For 2020, I'm pretty sure when I did it, I didn't get 20 meters per second. I don't know.
28?
Yeah.
What was the answer that it said?
It said 1 meter per second.
That's what the book says. We'll look at it in just a minute, okay? Double check your negatives. Sometimes negatives can throw you off there. I don't know if there should or not. I haven't looked at the problem in a while. So my friends that are working on this one with me, can we draw the picture real quick? So DT. So the initial for A is going to be positive 273. The initial for B looks like what? Slope of 0. Afterwards, the 273 is now going to slowly go negative, so something like this. And the one that was at rest is going to have a positive slope, but not nearly as positive as the other one, so something like that. Did I do that right?
Are you just thinking? Oh, yeah.
I'm not, like, this is very much a sketch, right? All I want is for these to kind of be relatively different from one another. You doing okay? All right. How are we doing, friends? Are there more homework ones that you want to go over, or are you feeling like this is helping? Is that okay? Cara, were there any other ones? Did you want to go over some more, or should we do something different for a little bit and then we can go over some more later?
Yeah.
Does that sound okay?
Yeah.
All right. So, physicists, I would like for you to take a pause on whatever problem you're on, put a little star where you're at or whatever so that you can remember what you're doing. I want to do a couple of quick conceptual things with you and then talk about the lab, and then I'll let you just keep working at the end. Does that sound okay? So we're going to regroup. Actually, I'm only going to do one conceptual one with you, and then we'll move on from there. So put your pencils down for a minute, wiggle your brain around, whatever you need to do. I'm going to pause this.